Hello everyone, my name is Victor Fagans, and today we're going to be reviewing some simple Dplyr and some functions that we used and I showcased in class that you'll be using in the homework assignment for this week. So this last week in class, I introduced packages. So packages you can think of as toolboxes that you can introduce to R to add more tools, to use different tools in R, add extra functionality, right? A package can contain data sets, it can contain functions, it can contain all sorts of stuff. And it's very handy. It's one of the really powerful things about R is that you can go out into the world and find packages that provide solutions to different things that you may want to do. For example, making graphs, manipulating data in a particular way, or even like make a website. There's packages for a lot of different things. So today we're going to be talking about Dplyr. So let me pull up my RStudio. So let me increase my font size here. Oop, there you go. So the way to get a package installed in R is to use the install packages function, right? And then in quotes you have the name of the package, right? So if you already have a package installed on your computer, you don't need to reinstall it every single time. And that's one of the reasons why I have this line of code commented out. I use this little hashtag to comment it out. And so when you download a package, once you have your package on your computer, you gain access to the package by using the library function. So library, and then you have the name of your package, and that line of code will give you access, will give your R session, like your R script, access to those functions so that you can use them for whatever analysis or workflow that you want to do. So when I run this command, library Dplyr, a couple of things is going to happen. So I'm going to get a message that's saying it's attaching the package Dplyr, right? So this is telling me that it is giving me access to that package. And then it gives me these two following things. It's saying following objects are masked from package stats, following objects are masked from package base, and these are functions that have the same name as functions that exist in Dplyr. So you can imagine that I have two toolboxes, right? And both toolboxes have a tool that is called hammer, right? But maybe they're different types of hammers, or maybe they do different things, but they both have the same name. And so R is letting me know that, hey, these functions have the same name. You should be aware of them, just in case there's any problems. And so we can see that, for example, if we look at the documentation of filter, so I'm using the question mark notation here on this function to look at the notation of filter. So here on the right on the help panel, we can see that two options show up. We have keep rows that match a condition, and that's from the Dplyr package. And then we also have this linear fitting filtering on a time series, and that's from the stats package. And so there's these two functions. They both have the name filter, but they come from different packages. And so most of the time, this isn't a problem unless you're working with a lot of different packages that have a lot of the same names of functions, which can cause problems. And so whenever we need to use a function from a particular package and we need to specify that function, we can use this syntax where we say, this is the package name, and then this is like where the function comes from, and we use these two colons, and then the filter with the function that we're interested in using. And so sometimes when you're working, you can work and it's working great. You have functions and everything's working fine. But say you now are using a new package. You install a new package and you load it into your R script, and things start breaking. Like, hey, this worked yesterday and it's not working today, right? So some things you can try is restarting R and see if that helps. Another thing you can try is maybe the function that you're using that there's a problem with has the same name as a function in a different package. And so now when you added that new package, you had that issue. And so to get around that, if that happens to you where something's not working and it's because about packages, you can preface with a function with where that function comes from, a package, and it'll solve that problem. Because if it's a problem with these different functions that have the same name, that's how you fix that. So for our class, we're only going to be using a couple packages, so we probably won't encounter that problem. But once you go into the real world and you start using all sorts of packages, then that can be a problem. So first, let's talk about filtering. So what is filtering? Filtering is a way to generate a smaller data frame from an existing data frame. So we have data that exists that has a lot of observations. So if we look at the education data CSV that we've been working with, right? So I'm going to load that up, right? And then I'm going to look at my environmental tab, right? That has 25,000 observations in that data frame, which is quite a lot of data. Now, if I table the sex column, so here I'm selecting the sex column, I'm using education data, $ notation, the sex column to select that, and I'm going to feed that into the table function. We can see that we have 12,000, around 13,000 females, around 12,000 male students in this data frame. And filtering is a way to decrease the size of a data frame by creating a subset that follows some condition. So if we look at the documentation of filter, so here's filter. I'm going to look at the documentation using the question mark command. And then here on the right, we get that two options. Again, we're going to select the first one because we're interested in the Dplyr filter. Right? And this documentation tells us a little bit of how this function works. Keeps rows that match a condition. Right? And it tells you a lot about kind of how this function works, what goes into it, right? But generally the idea is the first argument is a data frame, so it's some data that you want to subset. And then the ... here is where you kind of put your conditions, your logical conditions in your expressions to which the data is going to use that to evaluate what is in your subset. So here on the left here, back to the code, we have the first argument, we have the filter function. The first argument is education data, and then there's a comma, and then we have the second argument is this expression, sex equal to female, right? So we use two equal signs to ask the question, are these two things the same? So sex is a column that's in this data set that's either male or female, and this expression is going to evaluate to true or false depending on the value of the student. So if a student is male, then this is going to be false. So it's going to be male and equal to female. That's not true. It's false. When the student is female, this is going to be female equal to female, which is true. And so what this does is it's going to filter out the education data frame into a subset where this expression is true. So if we take a look at that, so I'm going to run this command, and I'm going to save that filter, the subset, into this object called edDataFemale. And I look at the sex column. So here I'm using the edDataFemale, and I'm looking at the sex column, and I'm tabling because I want to count how many female students there are, or male students, female students, right? And you can see here that we only have female students. So before, when we did the total education data, and we did the $ notation, and we did the table, we get male and female students. But now we only have female students because it's only for the female students that had the values of female in the sex column did this expression return true, right? So wherever this returns true, the expression is going to be what is included in the new data frame. So when we want to combine conditions, so we want to condition on multiple things, there's two ways to do that. We can use the AND operation and the OR operation. And so that's called Boolean logic. That's like the formal name of what it's called. And they have special symbols. So the AND filter uses the ampersand symbol. That's what this curly ampersand is. And how it works is whatever the expression is, so say I say true and false, right? True and false is going to result in false, right? True and false equals false. So you can imagine, and we'll see this in like actual examples, where if somebody was true, so say I am older than 18, but I'm not on the VIP list, then I am still considered, I can enter the party because I'm over 18 and I'm not on the VIP list. right? You can imagine back to our homework a couple weeks ago. That's what we did, right? But the way to remember about and is that with at least one false, everything is false, right? So and you need everything to be true for something, for the whole expression to be true. So for example, I have true and true, that results in true. False and false, that results in false. You see here on the bottom left here, false, false, right? True and false. So if there's at least one false, then the entire expression results in false. So let's take a look at sex and free and reduced price lunch. So here in the table, I'm using the table function, and I'm putting two inputs inside the table function. I'm using the free and reduced price lunch column, and I'm using the sex column. And what this does is going to count all the students in both those categories. So here's a table that was produced. So we see here you have female, male on the top, and on the rows we have eligible, not eligible. And these numbers in the middle represent the values of students that are in that category. So there's around 4,000 students that are female and eligible for free and reduced price lunch. There's 3,800 for male and eligible students, right? So this is the values of students that are meet this condition, or are in the data set. So say I did a filter, right? So I'm filtering here education data, and I have these two conditions. I say sex is equal to male and free and reduced price lunch eligible. So this condition, right, this part is going to be true for students who are male. This part is going to be true for students who are eligible. And this entire expression is going to be true for when students are male and are also eligible. So where is this statement going to be false? So it's and. So any one condition, any one of these conditions being false will result in the entire thing being false. So if a student was female, then they're not male and eligible for free press. If a student was not eligible, then this is false. They're not male and eligible. So I'm gonna use filter, and I'm gonna save this into a new data object. I'm gonna say add data male and free reduced price lunch. And now if I do that same command we did earlier, or I did a table, and I'm looking at the free and reduced price lunch column and the sex column, we get only one category, male and eligible. From before, we had the two, male, female, eligible, not eligible, but now we've filtered the data. So this data set's smaller and only contains students that met this condition, that were true for male and true for eligible free and reduced price lunch. So that's how AND works. AND is a way to combine conditions, and it's you need everything to be true. AND is for everything to be true. So let's talk about OR. So OR is kind of the opposite of AND. So you need at least one true, and then everything is true. So for AND, you need at least one false, and then everything is false for AND. But for OR, it's the opposite. You need at least one true, and everything is true. So if I say true or false, right? If I run that, I'm going to get true. That's the result of this expression. True or true results in true. False or false results in false. So true or false results in true, whereas true and false results in false. So let's see that in action. So here I'm going to use filter, the filter function again, right? And as a reminder, this function comes from the Dplyr package, right? So this is how we're able to use these functions. Education data, and I now have these two conditions. I have the sex equals female, or, right? So this vertical bar, which on my keyboard is like shift, it's the key right above the enter key, or free and reduced price lunch equal to eligible. So where is this statement, this expression, going to be true? This is going to be true for students who are female or free and reduced price lunch eligible. Now, where is this expression going to be false? For OR, everything needs to be false both expressions need to be false for this entire expression to be false. So sex female needs to be false. So for that to be false, that means the student needs to be male. For this expression to be false, then free and reduced price lunch has to be not eligible. So this statement is going to be true for all the students except students who are male and not eligible for reduced price lunch, right? So that's going to be those are the students that are false for this expression. So I'm going to save that into a new data frame, add data female or free reduced price lunch. Now I'm going to use the table again and use those two columns, free and reduced price lunch and sex. And here, you can see here, we have our table from before. And you can see here, we have a 0 here because students who are male and not eligible, that is when this expression was false. And so they were not included in the smaller data set. Okay? And just on a side note, right, we've been using character comparisons like equal to, but this works the same with greater than, less than, any comparison operator, any expression that produces a logic value will work with filter. So let's talk about not. So the not operator is this exclamation point. This exclamation point is the not operator. And what it does is like the opposite. It takes the opposite of a logic value, or you can think of it as like a negative of the logic value. So if I said not true, so not true is false, not false is true, right? So I'm running that line in R and it's evaluating to true. And I'm running that line, the exclamation true, it results in false. So the exclamation point it's the opposite. It's the way to reverse a logic. So say here, right, I have my filter function, education data. See, I have this expression here. I have sex equal to male, but then I wrap that expression in parentheses, and then I use this exclamation point. And so this exclamation point is going to negate the inside of this expression. So this is going to evaluate true for students who are male, false for students who are female, and then this exclamation point is going to reverse that. So it's going to give me observations that are not male. So here I'm going to save that into this object, not male, right? And I'm going to use the table on the sex column. I'm selecting this sex column with the $sign notation, right? And you can see here that there's only females in this smaller data set, the not male data set, because those students who are female are the only students that this expression is true, right? The students who are not male are female. Normally, this type of operation, we don't normally use the exclamation point in this form because there is an already operator that exists. It's called not equal to. Not equal to is an exclamation point equal sign, and that does the same exact thing as this operation. So using the exclamation point in this way, is not very common to say not equal to, because not equal to already exists as an operation. But there are some operators that don't have a not equal to, where this is very handy. So for example, here we have a filter, right? And I am saying education data, and then I have this expression. So this is a logical expression. If you may recall seeing it in our first homework. But this is taking the parent education column, right? So PARED column, and then it's using the in operator to then see it's going to look for parent education that are in this vector of options. So this expression is going to be true for any student that has a parent education of these categories, right? Less than high school, or some college, right? So this expression is going to be true for any student whose parent education, I call it less than college, right? So here I have parent education less than college, less college, right? So when I save that data frame and I use the table on the pared column, I have, and then it gives me only those students. The students, you can see the only things that show up are less than high school, and some college. Because for these students, right, that is where this expression is equal to true. And then when it's a student has a parent education that's not in this options, they're going to be excluded. They're going to be filtered out. So here we use the filter again, right? Education data. And now I've changed this expression. So you see it's the same parent education in that column, but now I've wrapped that in parentheses to do an exclamation point. So I have an exclamation point, and then I do this. So now I have that expression. See that in the parentheses under that expression. There we go. Then that's going to be negated. So this is basically saying not in. So parent education not in these groups. So it's going to give me all the students who have a parent education that are not in this group. And so I call that greater college, right? Greater than college, or maybe college or greater. So now when I look at the table, I'm going to see a bachelor's and graduate, and I'm going to see this blank. And we're going to talk about this blank in the homework. We'll be addressing this blank in the homework. But you can see that this not exclamation took all the options that were not these two. And this is true. Some students have a blank for their parent education, and that is true. True that it is not in this category. And so it's always good when thinking about not, like I call this greater than college, right? But we always should look at the values, because maybe this blank, I don't want it to be treated as greater than college, and maybe I want to do something else to it. And so you can see if I look at the unique, I'm using the unique function here on the parent education column. And you can see here we get this blank. So the blank value is what these students who have blank, they don't have a parent education value. So this not is also handy when working with missings. So we talked about missings briefly last week. We talked about NA. NA is a special value in R that indicates missing. But NA is a special particular value because whatever it touches, NA usually becomes NA. So if I say this expression, NA equal to NA, if I'm looking at this expression, NA equal to NA, I might think that that's going to evaluate as true, right? NA is equal to NA. But because how NAs work in R, anything that touches NA usually becomes NA. So if I say NA equal to NA, my result is NA, which is not what I was thinking of. I was thinking to be true. So when working with NA, we need to use a special function called is.NA. Is.NA returns a logical if a value is NA. So if I run that, is.NA with NA as the input results in true, right? Which is what we want. And you can see here RStudio is flagging this behavior as a warning and saying, hey, this doesn't work, all right? So because it's a very common problem, right? Like it's just not intuitive. You would think NA equal to NA would result in, true, but R doesn't work like that. So is.NA is the function you need. So education data, right? We're going to use a filter, right? And now in the expressions, we're using this function. So before, when we were doing filtering, we were using these kind of operators. We were using in, not equal to, equal, things like that, where we put something on the left and put something on the right, and there's some kind of comparison going on. But we can do any expression as long as it outputs a logic value. And so here, I'm using the is.NA function. So the is.NA is my expression that's going to evaluate the logic. So is.NA is going to use the fall reading score, is.NA, and that's going to result in the missing column. So where this is true is going to be where fall reading score is.NA. So I'm going to run that. And so now I'm going to use the table function. So remember, NA is a special value, and so I needed to add an extra argument to the table. Use NA equal to always. So this is going to include NAs in the counting in the table. So I'm going to select that column, FA read, right? Fall reading score. And you can see here I get 2003 NA values, right? And that it's just NA. There's no other values for fall reading score because this statement, this expression is NA, is true for all the students who are NA. Now, if I wanted to do the reverse and say, give me the students who are not NA, I can use the exclamation point. So I can say exclamation point is NA fall reading score, right? So filter education data not is NA, so it's not NA. And I'm going to say that into the object. FA read is not missing. And I'm going to use the same table. You can see here now I get the table, the counts for all the different scores, for all the different points. But now I see I have 0 for NA. NA is 0 now because that is false when not NA. Because if it's NA, then this is false. So in summary, right, we can use these expressions, these logical expressions, and we can combine not, and, or to look at particular subsets in our data. So generally, this is very useful for in contexts where we're only interested in a particular group of, say, students or particular observations. For example, if we were looking at states, we want to say, oh, I only want to look at schools in Texas. I only want to look at schools in California. Then we can use this logic to do that. And right, when we get more complicated, where our expressions get more complicated, we need to do multiple conditions. We can use the not and or conditions to do that. Right? And we can combine these, right, with any expressions or functions that produce logic values, right? Anything that produces a logic value, we can use in a filter. So let's talk about mutate. So mutate is how we transform columns in a data frame, right? This is the Dplyr way of changing columns. And so it's rather simple. We're creating a new column. So we use the mutate function, and we have our education data, and then we assign it into a new data frame or the existing data frame, depending if we want to save a copy or save, like, overwrite the data frame. Or we're using the assignment to overwrite the education data. So if I have mutate education data, and then I have this expression. So all the Dplyr functions work really similar, where they, or at least the main verbs in Dplyr work similar, where the first argument is this data frame, and then the second argument is like some kind of expressions, which will be that dictate kind of how that function is going to do what it does. So here, it says, here is the name of the column, the new name of the column. So I'm creating a new column in education data called reading ratio. And I say that's equal to, right? And so this is not equal, it's just one equal sign for representing the relationship. I'm setting a relationship between these two things. So fall reading score divided by spring reading score, and I'm saying that's equal to this column. So when I run that command, and then I use names, the names function on education data, you can see here now I have a new column in the data set that's called reading ratio. So that's how you can add columns. But we can also change existing columns. For STR, if we look at the structure of education data, we can see here the types of objects that the columns represent. So you can see here, this is public school ID or something, right? Some kind of ID variable. And it's an integer object. It's considered an integer, which is like a type of numeric. And so this object is an ID number, but maybe we don't want it to be an ID number. Like, does it make sense for student ID to be treated as a number? Like, can we add student IDs together, take the average of student ID? It doesn't make much sense for it to be a number. So we can transform it with the as character function. So here I'm using the mutate function again, education data, and then I have an expression, right, where I'm saying pub ID is equal to as character pub ID. So you can notice that this column, pub ID, and pub ID is on both sides of the formula, both sides of the equal sign. So that's the relationship, and that's going to overwrite pub ID. So it's no longer going to be an integer, it's going to be a character. So the as character takes things and turns them into characters, right? So if I run that command, and then I do structure education data, right, we're going to see that pub ID, right, is now a character. So it's no longer an integer. So we successfully overwrote that function, or that column, sorry. So another really handy function is the if-else function. So if-else is a conditional element selection. What does that mean? So if-else, what it does is it has 3 arguments. So the first argument is this test argument, and it just means it's a logical value. Basically, this just means like a logical value. And then the 2 other options are, what does the function output if this is a true value or this is a false value? So if this first argument is true, then it's going to output the value of yes. And then if this argument is false, then this is going to output the no value. So here I use it in an example. I have this vector is the first argument. It's the true, false, true. It's just a vector of simple logic values, right? And then I put as the yes argument is going to be 10 in quotes, and then no is going to be NA. So when I run that, so if you here on the bottom, I can see the output. So I ran that function. What it does is it gives me a vector that where basically it replaced all the true values with the yes value and all the false values with the no value. So all the trues were replaced with 10 and all the false values were replaced with NA because that's how I set it up. 10 and NA. And so this is really handy. So here's an example of its use, a use case. So say we're using the mutate again because we're working in column. We make a new column called high math. And then I use the if-else function where I say fall math greater than 5. Then I say if that's greater than 5, right? If this is greater than 5, if a student has a math score greater than 5, output this value, right? So where this statement is true, sorry, it keeps jumping to the left there. Give me this value. And if this statement is false, give me this value. So this is a very simple example with just one expression, but we can use all the logic rules that we learned before and or not to make this expression as complicated as we need it for our use case. But in this case, it's very simple. We just want to know high math score. So if it's greater than 5, give them a high math score. Otherwise, give them a low math score, right? With categories. And so if I run that command, then I run the table command, I get 22,000 students that are in high math and 147 students that are low math. So there's not a lot of students that have a less than or equal to a score of 5 on their fall math. So that's mutate. Mutate's very flexible, but that's the kind of high level construct is you just give it a data frame and then you do relationships between columns. And really where you get more knowledgeable about mutate and how to work with data frames is the use of the functions, right? How do I use the functions in R? What are the functions that I know about to solve whatever problem I'm trying to solve? So let's talk about renaming columns. So renaming columns, it makes things, it can make things either easier to read or kind of easier to work with. So if we look at the names of education data, right, we see here that here's the names of all the columns we've added, and right, and these are the 2 names that we added for new columns. So education data clean, right? So we can use the rename function, right? Education data, and then the second part of that function, the rename. So if we look at the documentation of rename, you can see that it'd be very similar to the rest. Rename, right? So rename, it has data and then the dot dot dot. And what does the dot 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 look like? You can use, it uses this syntax. New name equals old name, right? To rename selected variables. So in class a couple weeks ago, we talked about this PA red variable, and that if we didn't know what this data set was about, then it might be tricky to figure out what does this column represent. And so we can rename that column into something that's a bit easier to read. So for example, parent education. Here's another example. So I have a comma here. So before we were using mutate filter, mutate with just one, working with one column at a time. but we can work with multiple columns by adding extra arguments, by putting comma and then adding extra arguments. So parent education equal to parent ed, bar ed, right? So we're renaming this column, which is the old name, into a new name, parent education, because this is clear for what this column represents. Pub ID, if we were looking at this column and we're like pub ID, I don't know what pub ID means, we can rename it to student ID. And then that's easier to understand what is that column. So I'm going to use this rename function. I'm going to save it into this data frame called data clean. If I run that, data clean, then if I look at the names of that new data frame that we made, you can see here that, let's see here, student ID is in there, parent education's in there, right? And because those old columns, pub ID and parent education par ed function column was renamed. So we renamed it to something a little bit more legible to what it means. Another function that we didn't talk about in class is the select column. And it allows us to select and drop columns of interest. So if I did select and then use my data frame, and then I can give it columns that I'm interested in. And then this is only going to give me a data frame that only contains those columns. Right? So if I do names only pub ID, then you can see here only pub ID shows up, that column. And right, this code here, selecting this, is the same, basically the same thing as doing this. Education data $ pub ID. Right, that gives me the vector of pub ID. Right, that's the same thing as what this function does. Another thing about select is you can also drop columns of interest. So if you use the negative sign on a column, then you can drop that column. So if I do education data and I select -sign sex, right, I'm saving that to drop sex. Names of that drop sex, you can see that sex is no longer in the column name, so we dropped it. And so select functions, there's a lot of really fancy ways and nuance to when we're selecting columns, especially when we're working with a lot of different columns. And to that kind of shows, like, when we start working with packages and functions, it's kind of hard to memorize everything, like absolutely everything. You saw throughout this review, I was looking at the documentation, and that's a really good habit to get when you're working with a new function. Pull up the documentation, right? That's the documentation is when we do the question sign, and then we do a function, right? And we get in the help column, we get to see how that function works. So documentation is really helpful when you start learning these new functions, and learning a new package in particular, because a package is a toolbox that has a lot of different tools in it, and we're not exactly sure all the tools inside the toolbox. So the documentation really helps. And I will say, let me change my screen here. So there's a website, the Dplyr website, which it contains a lot of really helpful information for learning more about Dplyr, examples, different functions, and different things. And so when you're working on a problem and you're like, hey, I want to do this particular thing, and I don't know the tool to do it, go to the internet and explore kind of what options are available. So the Dplyr package has a really nice website where they have references and examples and instructions. Here's a cheat sheet where it gives you kind of a high level quick overview of what different functions do. And so whenever I am learning a new package, and if it's a tidyverse package, so a package that's very well like documented, then they have a cheat sheet like this. I'll look at the cheat sheet and be like, which one of these tasks is it that I'm interested in doing? And then that'll be like, oh, I didn't know about the pull function, but that's what I need. That's what I need right now. So I'm going to use the pull function, stuff like that. So yeah, so that's Dplyr. That's a quick review. Or I say quick. It's been like 40 minutes. It's basically a relecture. But things get more complicated when we use packages, right? There's like more things to keep track of. But that's where documentation comes in hand, right? You don't need to have everything absolutely memorized, right? We're constantly using resources and using the internet to remind and refresh ourselves, like, what does this function do again? How does it behave again? Because as there's hundreds and hundreds of functions, it's hard to keep track of them all, right? It's only through experience will you become more familiar with the tools? Okay, so that's this review. I say review is basically a relecture, but thank you for having me, and feel free to, ask questions in class about how Dplyr works. Yeah. All right. Bye bye.